Let's take a look at the intermolecular forces for CH4. This is methane. The first question we need to ask with intermolecular forces is, do we have any ions present? Since we don't have a negative or a positive here, we know that this isn't an ion. So there are no ions present, so we can get rid of all this right here. Next, since there are no ions present, we need to ask, are there polar molecules present? So is CH4 a polar molecule? And the way to do that, we can look at a Lewis structure for CH4, and that shows us that we have the 4 hydrogens bonded to the carbon, but really we need to understand the molecular geometry for methane to know whether it's polar or nonpolar. And since the difference in electronegativity between carbon and hydrogen isn't that great, we would expect this to be nonpolar. Let's take a look at the molecular geometry quickly. So for methane, we have that carbon in the center surrounded by hydrogens. In all of the hydrogens, they're pointed in opposite directions. They're all pointed in different directions, mathematically equivalent directions. So we end up with absolutely no net dipole for methane. So we don't have polar molecules present. So no polar molecules present, we go down. And the only intermolecular forces present for CH4 here, those are London Dispersion Forces. When we talk about London Dispersion Forces, these are temporary dipoles. They occur in our nonpolar molecules, like CH4, and that's where you have a sample of CH4, and some of the molecules can induce a dipole in another methane molecule, another CH4 molecule near it. That creates a temporary attraction, and that's the intermolecular force for CH4, London Dispersion Forces. This is Dr. B. Thanks for watching.